In this tutorial, you will see how easily you can broadcast and view your sensor readings through ChipChop. For this project, I will be using a simple DHT11 temperature and humidity sensor, but you can use anything you like. This method applies to any type of device and any type of component. So first thing, let's go into the ChipChop development console, and in the devices section we need to create a virtual representation of the device that we will be building. So this one, I know it's just a silly little sensor on a breadboard, but I'm going to give it a big name and I'm going to call it weather station. And unique ID, again same thing, just lowercase with an underscore. As components, we will have two. We will have temperature, and the type of component, we have temperature type. It's view only. We can't really interact with the temperature or humidity sensor. We can just view their readings, so that stays as view only. And we're adding another component, which is humidity, and again we do have a humidity type, and it's view only mode. Date and save. If we look under live control, we can now see the device showing there in the list, the weather station, but there's nothing to display until we've actually programmed the device and connected it to ChipChop. If you haven't done so already, in the download section you can find the download for the ChipChop Arduino library and also the links for the tutorials and the library documentation page. You should watch the tutorials so you know how to install and set it all up. So what I've done is I've created a small platform IO project, and I've called it Weather Station, and here it is. In the lib folder I've included the ChipChop library and the WebSockets too, and all I had to do is just add the DHT drivers for the DHT sensor. These ones are from the Adafruit Industries and they're a part of the Adafruit Unified Sensor Library. They work perfectly and there was nothing else I really needed to build this device, just this little library. So if we look at the code, if you've watched the Smart LED tutorial and if you were to compare this code with the Smart LED, you will probably notice that it's almost identical. There's not much going on here, not much you need to do. So I'll just run you through quickly. We're including the ChipChop library here, giving our device ID, which is exactly the same as we've specified earlier in the development console, and also we have the ChipChop security credentials, and then here I'm including the DHT driver library for the sensor and also specifying which pin I'm listening to, and also preparing two variables that I can store the readings from. The next in the setup, standard connecting to the Wi-Fi code, and then here we are starting the ChipChop library by passing the security credentials. I'm going to leave the ChipChop debug to true, so we can watch what's happening once we are connected to the ChipChop engine and the messages being exchanged between the device and the ChipChop engine. And I'm starting the sensor itself here. In the main loop, we're running the ChipChop library continuously. That's very important, and we're not using any delay function because that can block the run loop and the running of the library, and it will block the running of the WebSockets. So we're just using a non-blocking method to check every 10 seconds. We're going to read take the sensor readings, so we're going to read the temperature, read the humidity, and then finally this is the main part. So all of that was just a foreplay, just an intro. The clever stuff happens in these two lines of code here. So what we are actually saying here is we're telling the ChipChop library to update the status for the temperature component with this value of this variable. And we're repeating the same thing for the humidity component, humidity value. That's it. That's all you have to do. You don't even need to keep this 10-second check in the main loop. The ChipChop library handles that automatically for you. The reason why we have this little delay here is actually because of the sensor itself. These cheap sensors, they don't like to be pushed too fast, otherwise they can overheat and give you some rubbish information. So we're just giving the sensor 10 seconds break before we ask it to read again the temperature and the humidity. And that's it. That's all you need to do, and effectively we have a tiny little weather station going on here. So I'm going to push this onto the device, and whilst this is compiling, I will show you what I've built. And this is my little weather station. We have a DHT11 sensor here, we have an ESP8266, and we have 5 wires. That's it. That's all we needed for this little project. And here we go. We've compiled successfully the code onto the device, and I'm going to open now the serial monitor, and let's see what happens. So we're trying to connect to the Wi-Fi, and here we go. ChipChop. Well, we're trying to send the heartbeat before we are actually connected to the ChipChop engine, but don't worry, this is quite normal. And there we go. We're opening the connection here. We have connected the socket. We have received the handshake security request from the ChipChop engine. We've confirmed it all in the background, and we've got a howdy partner welcoming message. And here we go. We are now sending every 10 seconds the heartbeat, and we can see the status of the temperature value is 27.10 degrees, that's in Celsius, and the humidity is 57%. And to show you what that really looks like, I'm going to split my screen, so reduce this and bring back the development console, and let's squish this like that. Okay, and go back into the live control, and here it is. This is our weather station, and if I click on it, we can see now the temperature and the humidity showing. You will get exactly the same thing in the web app on your mobile phone, so you can monitor the status of your sensor at any time you want. Now, I thought what would be really funny is to show you something a little bit smarter than just monitoring this, the status of the readings. So what I've done is I've built another device, and this one is another ESP8266, but this one has a little fan. I hope you can see this. There we go. So we have a little fan here. So they're two completely separate things, and they could be in completely different places, different part of the world. So if this one we call a weather station, well, let's call this one the air conditioning unit. So what are we going to do now? Let's go back into the development console, and under the actions, let's create an action that when let's say a humidity rises too high in our weather station, that it will trigger and start the fan in our air conditioning unit. And this is how we'll do this. We'll create a new action, and let's call it humidity high. Oh no, let's call it aircon on. We'll make it active, and then as a trigger device we'll choose our weather station, and the trigger component will choose the humidity, and we will say that if the humidity is more than, so what is our current humidity here? It's 57, I think. Humidity is, yeah, it's 57. So let's say if the humidity is more than, let's say 58, the target will be our aircon and the component will be the fan, and let's turn it on anytime, every day. Save. Simple as that. And then let's do the reverse and create another action and call it aircon off. Oops, mistype. And make it active and say trigger device, weather station, humidity, and when it's less than 58, we will say that our target device, the aircon fan component value is off. Save. Okay. So how are we going to emulate this? Well, I have a trusty vape. Yeah, unhealthy habit, filthy and horrible, but it's useful for testing. So I'm going to blow a little bit of steam onto the sensor. And let's see if the humidity is going to go up. Now bear in mind, these are cheap and nasty little sensors, only good for demonstrations like this, so it may take a little bit till it registered the change in humidity. Oh, here we go. Humidity has risen to 62%. Let's have a look in the live control. Weather station, yep, humidity is 62, and also the aircon fan is on. Even if I was to stop this fan now, it will start again. You will see on the next heartbeat, go, it's starting again. So what's going on here is that every time our little weather station sends its heartbeat with the value, the humidity value, the actions get checked. And if this criteria in the on is valid, the action will get executed. So our fan is on, but now the humidity is dropping lower. And I think we said once it drops below 58, it should switch the fan off automatically. I don't know how long that's going to take, so I'll fast forward the video until we get to that. And here we go, the fan has stopped. So, I hope you have enjoyed that, and you know now how to view your sensor readings through ChipChop. Have fun!